Today we're going to learn how to solve polynomials. And the reason why I know we're going to solve polynomials today is because we have this equals 0. So whenever you have an equals 0, you know you're solving it or you're trying to find what x equals. So for this problem, you should realize, first off, you want to know how many answers you're going to have. And we're always going to have the same number of answers as we have roots. So I should end up with 4 answers. Now, when you have 4 answers, you don't know how many are going to be imaginary and how many are going to be real, but we'll find that out soon enough. So the first thing that I would do for this problem is I would try to factor it, because factoring seems like the easiest method to use, and that's the only one we know how to work with. And if you remember from before, you see how this is to the 4th power and this is to the 2nd power? Well, it's just like our normal factoring, except instead of just using x, we're going to have x squared, because they need to equal our 2nd powers. And then once we get to here, again, it's the same game we've always played, which is what multiplies together to give you negative 18 and add together to give you 7. And the answer to that would be positive 9 and negative 2. And then once you have it to here, we want to know what makes this thing equal 0 and what makes this thing equal 0. So we'll write that out. We'll say x squared plus 9 equals 0 and x squared minus 2 equals 0. Well, now from here we can solve it by subtracting 9 on each side or adding 2 on each side, and getting x squared equals negative 9 and x squared equals 2. Then what we'd want to do is we'd want to take the square root of both sides. So when I take the square root of both sides, you should remember anytime we take a square root, you want to get a plus or minus. Now, I don't know what the square root of, well, I do know what the square root of negative 9 is. It's 3i, because we don't know negative numbers, so we put an I on the end. I don't know what the square root of 2 is, so I'm just going to put plus or minus radical 2. And again, it makes sense from our original thing, because I look at this and I have a plus and minus here, and I have a plus and minus here. So I have a total of 4 answers. Let's try the next one. Before we start this problem off, how many answers should I get? Hopefully you said 4, because this is a degree 4 polynomial. So let's do the same method we did before. We're going to factor this thing. Now what should go right here? Hopefully you said x squared and x squared, because again, we want them to multiply to be x to the 4th, and then give us x squared in the middle. And now we want to think about what factors are going to make me multiply to get 15 and add together to give me 8. For that, hopefully you said 5 and 3. Now again, at this point, we want to make these things equal 0. So we're going to say x squared plus 5 equals 0. And x squared plus 3 equals 0. And from here, we're going to solve it by subtracting 5 on each side and getting x squared equals negative 5. And subtracting 3 on each side and getting x squared equals negative 3. At this point, we want to take the square root. And whenever we take a square root, we know that we get a plus or minus. Now this time I'm not pulling out an I because I don't know what the square root of 5 is. And I'm not pulling out a I here because I don't know what the square root of 3 is. But again, you can count our answers. And we have 1, 2, 3, 4 answers. And last time we had some real answers and imaginary answers. This time we just have 4 imaginary answers because you have square roots of negative numbers. So if you were to graph this thing, you'd have nothing that crosses this x-axis. It'd kind of probably float up here somewhere, and you'd have nothing that crosses it. Let's try another problem. In this problem here, you should notice 2 things that are different. First, this is the first time we've had a 3rd degree, so we should end up with 3 answers. And second, you should notice that every single term has an x. If every single term has an x, before the problem starts, we want to pull out what's common across everything. So we're going to take out an x from everything. And if you look at the numbers they all share is 4. So we should be able to take out a 4 with it. So I'll put a 4 on the outside here. That would be x squared. This would be minus 4x. And this would just be 3. And that should equal 0. Now at this stage, we'd want to try to factor this inside portion. When I try to factor this inside portion, I'm going to get x minus 3 and x minus 1, because again, we always want to think about what we'll multiply together to give us this and add together to give us this. Now this time your zeros are a little bit trickier. What my zeros would be for this case would be 3, because I could make that equal 0. 1, because that makes it easy to equal 0. And if you're wondering what this one would be, well, you'd say 4x equals 0. Divide both sides by 4. So that means x would be 0. So your 3 zeros are 0, 3, and 1. And you'll find out that every time you have an x in front, that it's going to be 0 as one of your zeros. So again, we thought so it was a third degree, and this thing has 3 real zeros. Let's try another one. So my first question is, what could I factor out of all these terms? And the answer you should come up with is x. We could take an x out of each one of these terms. And at this point, we then are going to look on the inside and see if this thing factors. When I look to see if this thing factors, it does. And it should factor into x plus 4 and x minus 1. Because 4 times 1 gives you negative 4, and 4 minus 1 is 3. And again, we want to find our zeros. If you remember from last time, your 3 zeros should be 0, negative 4, and 1. And those should be our answers. Again, we could graph this thing. It's now finally in factored form, so it's the easiest form to graph. Let's try another one. When I look at this one, I want to ask the same question. What could I factor out of it? And the answer is, you could factor out an x. Now you might want to just say 5x, but that's not true, because not all of these things are divisible by 5. So this would become x squared, 5x squared minus 5x minus 12 equals 0. Now we'd want to try to factor the inside part, but this 5 out in front makes it really, really difficult. And so because this is a little bit more difficult to factor, instead of factoring to find our zeros, another way you can solve a quadratic, because this quadratic would equal 0, would be the quadratic formula. So we're just going to plug that thing into the quadratic formula. The other 0 that we have, if we remember from before, x equals 0, so that one's 0. And the other two we'll find by using the quadratic formula. If you remember the quadratic formula, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So when I do this, my b term is negative 5, so I get a positive 5. Negative 5 squared is 25, minus 4, and a in this case is 5, and c in this case is negative 12. And then 2 times a would be 10. Now at this stage right here, we'd want to do this inside of the square root, which isn't too bad to do. We would just have to, on a calculator, to do 25 minus 4 times 5 times negative 12, and you would find that that gives you 265. So we'd have 5 plus or minus the square root of 265 over 10. And if you take the square root of 265 on a calculator, you would find that it's not a nice number. So we'll actually just leave it as this for our final answer. Let's do one more problem. When you look at this, you should recognize that this is a difference of cubes. So factoring this is using one of those two formulas we learned yesterday. So the formula I'd want to use would be a minus b, a squared plus ba plus b squared. So in this case, I know what a is. A is x. B is a little bit trickier because we have to take 64 and cube root it. Or another way of saying that is take 64 to the 1/3 power. Make sure you put parentheses around the third. And you'd get that to be 4. So we know that this would be 4. I would then plug everything in. So I'd get x minus 4, x squared minus or plus 4x plus 16. And then when I'm looking at that, again, this one's really easy to do. That 0 is 4. This will not factor. So if it won't factor, I probably want to use the quadratic formula. So that would be negative 4 plus or minus the square root of b squared, which would be 16, minus 4 times 1 times 16 all over 2, because 2 times 1 is 2. At this stage, again, we'd want to get the inside of that square root. The inside of that square root would become negative 48. Again, you could throw it in on your calculator to see. But as soon as I get it like that, I know that I really don't want to do the square. The square root of 48 doesn't work out. I mean, you can try it. Whoops. You can try, if I can click the right button, you can try it. And you can see that I get 6.9. So, and it's a negative, so you have that imaginary answers. So you'll just realize that one of your answers is 4 and the other is 2 imaginary numbers. So that's how we kind of go through and solve it. You want to factor it, and if you can factor it nicely, then you get these nice zeros. If you can't factor it, then you want to use the quadratic formula to find your zeros. Try the different problems for today.